Assalamualaikum warahmatullahi wabarakatuh. Today I want to explain about the uh, experimentally flywheel apparatus. Okay, this is the procedure that the apparatus that we can use for this experiment. Okay. Okay. For the procedure, the step 1 is measure the dimension of the disc and axle by using proper instruments. Repeat the measurement and take the average result. Okay. And then wind the string around the axle. Record the number of turns and then make sure that the string is hanger freely. Place a weight hanger to the string holder. The third step is suspend 0.4 kg of load, which is in M, on the string and take the time after releasing the mass from the rest until it reach the minimum point. And then repeat step 2 and also the step 3 and get the average readings. Record the result into the table. Repeat step 1, 2 and also the 3 with every 0.4 kg increments until 2 kg. And the next step is calculate the mass of the disc and axle using the equation of rho equal to mv. Given density of the flywheel is 7,870 kg per meter cube. And the next step is determine the angular accelerations, linear acceleration, and also the moment applied to the disc and axle for each value of m. Plot a graph of moments against corresponding values of angular accelerations and determine the slope of a base straight line representing the plot point and find the experimental moment of inertia. Calculate the displacement of inertia of the disc and the axle. And given the density of the disc axle is density of axle. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today I want to explain about the first objective. My name is Muhammad Nabil bin Hanis. My student ID is 2019257768. Okay, for the first is the objective of the flywheel apparatus experiments is to verify Newton's second law for a rotation motion, which is m equal to I m equal to I alpha to determine the moment of inertia of a disc and axle from experiment. They determine the frictional moment required to overcome the friction, and lastly is to determine the moment of inertia of a disc and axle using a theoretical equation. Okay, this is the result that we get from the experiments procedure. The flywheel disc diameter in meter we get 0.304 meter, and the axle diameter is 0.024 meter. The flywheel depth is 0.04 meter. The axle length is 0.368 meter, and also the number of turn string on axle per revolution is 8 revolution. Okay, the drop taken for each mass from the rest to minimum point. Okay, for the load 0.4 kilogram, we get the time is 15.81 for the first time, and the second time is 15.34 and as a 15.84. The average we get is 15.66 seconds. Okay, then we repeat the experiment with 0.8 kilogram and also the 1.2 kilogram, and we add for the 1.6 and also the 2 kilogram. Okay, this is the average that we get from the experiment. Okay, and then we calculate the angular accelerations and also the moment calculation for the based on the time that we get. Okay, from lot 0.4 we get the angular acceleration of 0.205. The linear acceleration we get 2.460 e dash 03, and the moment in Newton meter is 0.05541. Okay, this is the table that shows the different the difference weight. Okay, next is calculate from the experiment table. Okay, the experiment we get 0.0541 from for the 0.4 load kilogram, and the theory we get the 0.0471. The percentage that we get is 14.86. Okay, so we calculate also the 0.8 and 1.2 and also until the 2 kilogram, and this is the percentage of error that we conclude from the experiment that we made. Okay, this is the graph for the moment versus angular accelerations, which is the moment that we get. We we compare into the angular acceleration that we get. Okay, for the discussions, the first is draw the free body diagram and kinetic diagram for the flywheel and wake. Okay, this is the free body diagram for the flywheel. And the wake that we get for the flywheel, and this is the kinetic diagram. Okay, next is the next question is compare and discuss the result of the drop time and moment of inertia for various weight of the flywheel apparatus using the theoretical equation, and also compare the measurement in the experiment. Okay, first, the average time for each weight in the experiment was used to compute the drop time for varied weight. And next, then the second is the larger the weight, the shorter the time recorded. We can reduce from deduce from the results. Okay, third is third is the experimental has a higher value in the system right now, whereas the theoretical has a lower value. The third is give your comment or suggest at least 4 causes of the error that may affect the rules of the experiments. Okay. Uh, every experiment that we made, uh, it can make some of the error that can happen. Okay, the first is when conducting the experiments, parallax may occur. When we use the measure tape to measure the diameter of both and this and axis, this can happen. The scale of the measuring tape is not at right angle for our eyes. But parallax error can be eliminated by close observations or taking the average length. And second is then there is possibility of human error as a result of negligence. This can be seen in the experiment method, where we must take the average time because of the time delay while pressing the stopwatch. This happens. Taking at the average time taken can help with this. Then there's the possibility of an instrumental error. When the string holder collides with this occur. To improve this, we need to leave enough space between the string holder and this so that we can accurately fill in the table. And lastly is there are transcription mistake that
can occur. It happens when the data is entered inaccurately, particularly during calculations. This can be improved by repeatedly monitoring the calculations. Okay, for the conclusion of the experiments is the experiment based of the Newton's second law is discovered utilizing the m equal to 1 equations, which is the I alpha. Using the theoretical equations, we can also get the moment of the inertia of this axle. The frictional moment required to overcome the frictions and also the moment of inertia of this axle. The flywheel disc will rotate around the fixed axis. The graph of moment vs versus angular acceleration can obtained by computing the moment and angular acceleration from the experimental measurement. Because the experimental and theoretical values are different, the percentage of error for the experiment between the theoretical value achieved is very considerable as shown in the data. Okay, during the experiments, make sure that the string holder does not clash with the disc. Is to make hanging the weight hanger easier. Also, ensure that the location where the effort is made is clean to avoid the undesired items. Okay, that's all for my presentations for the experimentary of flywheel apparatus. Thank you very much.